Greetings and welcome to the Plsql Challenge, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein, and I'm a Plsql developer just like you. This lesson is part of my series on error management in Plsql, and the focus of this lesson is on continuing past exceptions with DBMS Errorlog and log errors. Just some quick reminders. You can download all the code in the PowerPoint document supporting this webinar from Plsql Obsession, which is toadworld.com/myinitials, SF. And if you visit this website, you will find lots and lots of resources for Plsql developers. If you click here, you can download my demo zip with all the files that I'll be referencing in my trainings. If you click here, you can drill down to my training seminars and presentations and download the PowerPoint for this webinar, in fact, for the entire error management series. Make sure you're comfortable with the previous material covered in the previous lessons in this series, basic concepts of error management, defining, raising, and handling exceptions. All right then, let's dive in. So DBMS Errorlog and log errors, the agenda. First of all, we'll talk about the impact of errors on DML execution, the execution of updates, inserts, and deletes. I'll introduce you to the log errors feature. We'll take a look at creating an error log table, how we add the log errors clause to your DML statement, and then we'll take a look at some gotchas in the log errors feature because it's not as beautiful and wonderful and perfect as it could be. Finally, I'll introduce to you a helper package that I wrote to make it easier to work with DBMS Errorlog. All right then, impact of errors on DML execution. Now, as you probably are aware, when you execute an SQL statement like update employee set last name equal to X, that statement can result in changes to multiple rows. In other words, each row modified by the DML statement is modified separately. So what happens when an error occurs on a change to a row? Well, first of all previous changes from that statement are rolled back. In other words, if I'm updating 100 rows with my single update statement, and I finish 50, and then in the 51st row, I get an error. The previous 50 row changes are rolled back. And no other processing of the rows, the rest of the rows are done. And an error code, an Oracle error, is then passed out from the calling block, which turns it into a Plsql exception. And one thing to note also is that no rollback occurs on completed DML in that session. In other words, just because the current DML statement failed doesn't mean that the impact of previously successful DML statements in your session are rolled back. They're not connected at all. You might decide to do a rollback if an error occurs on this DML statement, but that's up to you to do. Usually, this approach is acceptable. In other words, your update statement, your insert, your delete, it's an all or nothing proposition. Either it modifies all the rows specified or none. But what if you want to do instead avoid losing all those prior changes? What if you want to be able to keep going past those errors in those rows because you might be updating lots and lots of rows? And also you want to avoid the performance penalty of exception management in Plsql. Once an exception is raised back to Plsql, things come to a halt. Your application, well, slows down considerably. And in general, error or exception handling is a slow process in Plsql. So maybe you want to be able to avoid that. And that's what the log errors feature will do. Now, before we dive into those details, let's go back and take a look at an example of what I just explained about how the error management works for a single DML statement. So we'll take a look at the errors in DML script. Okay, so I'm working with the employees table. The employees has a salary column, and the salary column is, let's see, salary, maximum number 8, 2. So there's a constraint on the size of the number that you can have for a salary. Now what I want to do is give everybody a really big salary, multiply their salary, their current salary by 200. And the question is that really possible? Could everybody actually get that increase in salary? So what I'm going to do is declare a variable using the salary column as its type, which means the constraint on the size is carried into my Plsql code. I'll try to assign that really big new salary to the current salary, or the salary variable. If it was successful, I'll display new salary. Otherwise, I'll trap the exception and display the error. So first of all, let's run this code. And when I run it, what I find is that some people could get a new salary. But for other people, the number became too big. In other words, their current salary is so big already that multiplying by 200 pushes it past the precision for that column. And as you can see, some can make it, some can't. Okay, so clearly there's a mix there. Now, let's go back to the issue of DML. Let's get rid of this screen. Okay. So now what I want to do is actually run the update statement. So what I'm going to do is select the number of employees who are currently making more than $24,000 and see how many there are. Then I'm going to try to update everybody's salary to that new enormous salary. In other words, one update statement, and it will be executed for each row in the table, 107 rows in total. And then I'm going to check to see how many employees now make that much money in my executable section. And if something went wrong, I'll display the error. And then see how many rows were modified, how many people are now making $24,000. I run the script, and here's what I see. Before, nobody was making that much money. Then I got the error, value larger than specified precision allowed for this column. And then afterwards, nobody was making this amount of money. So even though, as you could see, there were people who were able to get the salary increase, when I run it as a DML statement like this, then you cannot apply the update to any individual row. In other words, as soon as I hit that first error, all the changes to the existing rows were rolled back. So that's the default behavior of DML. And again, that might be perfectly fine, and in fact it is generally fine for a lot of your applications. But in some situations, if you have many, many rows that you're updating or deleting, you might want to not stop when that error occurs, but keep on going. So let's take a look at how you can do that. And what we're going to talk about here is row-level error suppression in DML with log errors. So once the error propagates out to the Plsql layer, in other words, Oracle has stopped the DML statement, it's issued an error, Oracle error, and it goes back to the Plsql block, all the changes to rows have been rolled back. The only way to preserve those changes to rows is to add the log errors clause to your DML statement. And when you do this, and you've properly set things up, then errors are suppressed at the row level. In other words, as each row, the change occurs for that row, if an error is raised, Oracle traps that error inside the SQL layer, and as we're going to see, writes the information to a table, and then keeps on going. This is the only way I know to be able to do this kind of row-level suppression, and the only way you'll get it to work is if you first create an Errorlog table with the DBMS Errorlog package. So this feature that we're talking about, row-level suppression, involves using the DBMS Errorlog package and the log errors clause, and we'll look at both of these in great detail. So first of all, let's talk about some terminology when working with the log errors feature. So we'll refer to something as the DML table, and that's the table on which DML operations will be performed. So if I say update employees, set last name equal to null, the DML table is the employees table. And then there's the error logging table or error table, and that's the table that will contain a history of all the errors generated when you executed DML operations against that table. And then there's the concept of the reject limit. You can specify the maximum number of errors that are acceptable for a given DML statement. Basically, you can say, well, you can say reject limit unlimited. In other words, I don't care how many errors occur, just keep going. Or you can say, wow, if I get more than 100 errors for this DML statement, something's badly wrong. Just stop. I need to take a look at what's going on. So you'll have that flexibility. Okay, so let's take it step by step. Step one, you need to create an error log table. Basically what's going on with the log errors clause is that instead of raising the exception out to Plsql, it's going to write a row of information out to your error log table. And you create the error log table by calling DBMS Errorlog create error log. And that will by default create an error logging table that has the name error dollar and then your table name, so error dollar underscore employees, error dollar underscore departments, etc. Of course, since you can't have table names that are greater than 25 characters, you can specify an alternative table name, as well as table space and owner for the table and all those kinds of things through this parameter, through this procedure call. And what will happen, and I'll demonstrate this to you in just a second, is that the error logging table will be created with 5 standard error logging columns, keep track of the error number, the error message, etc. And then it will also add a column to the error log table for each varchar2 compatible column in the DML table. So let's run through an example of creating this table. We'll take a look at the structure, and I'll come back to some of the details mentioned here. Okay, so in my DBMS Errorlog script, I'm going to call DBMS Errorlog create Errorlog. And as you can see, I'm passing it the DML table name as employees. Now the full interface for this package is as follows. Create Errorlog, pass in the DML table name, and then alternatively, and these are, you don't have to pass them, an alternative table name, owner, table space, and whether or not you want to skip unsupported column types. And I'll come to that after we look at the table that's constructed. So let's run this statement. I'm going to create my Errorlog table. Now if we go back over to my schema browser and look at that table, let's refresh the list. Here's error $employees, and what you see is the Oracle error number at the time the error occurred, the error message, the row ID, the operation type, update, insert, delete, and the tag, which is basically an optional column that you can populate with data from your DML statement. And then, for every one of the columns in my employees table, it added a column, all of varchar2 4000. In other words, it's a string representation of whatever was in that column at the time the error occurred. So numbers, strings, dates can all be converted to varchar2. But there are other data types that cannot be converted and could cause problems, like blobs, collections, object types, and so on. So if you have a table with one of those unusual column types, you need to say skip unsupported when you create your database Errorlog table. Let's go back to that interface. You'll need to say skip unsupported is true. Otherwise, it will error out. It will not create the table for you. So I just created my Errorlog table, and it tracks both standard error information and then table-specific information. And now let's take a look at using it. Oh, so sorry, that's the Errorlog table. Let's go back and continue the exploration. Step 2, now you've got the Errorlog table in place. That's good. But now you have to tell Oracle that for a specific DML statement you want to use the Errorlog. And that involves using the log error statement. So you simply add to your DML statement the log errors clause, and then you can specify the reject size, either limit unlimited or limit an integer value. And as I said before, what this is allowing you to specify is if things are going badly wrong, you shouldn't be getting so many errors, so you want to just stop. In some cases, you'll just say, I don't care how many errors occur, just keep on going, get everything done you possibly can. So you have that option. And the other thing to remember is that if you're going to use the log errors clause, you have to make sure to check the Errorlog table after you run your DML statement, because even if errors occur in your DML statement, Oracle will not raise an exception when it's done. In other words, there'll be no evidence inside Plsql, or whatever block calls this SQL statement. There will be no evidence that an error occurred, which is quite different from save exceptions in for all, which is covered in the previous lesson in the series. With save exceptions, it'll continue past exceptions in your DML statements at the statement level, but when it's done, Oracle raises the -24,381 exception. In this case, there's no visible evidence of the error. You have to look inside that table. All right, let's give it a try before we go into the gotchas. So I've created my Errorlog table. Now let's go back to my original script in which I tried to update. I tried to perform an update saying set everybody's salary to the same salary times 200. And remember that the before and after showed me that no change was made. It hit a problem and it rolled back all the changes to the row. I'm going to run it again. I'm going to check to see how many people make 24,000. Do my update, set my reject limit to unlimited, and then see how many people are now making $24,000. And notice there's no exception section at all, no exception handling whatsoever. I run my script and I see some very different behavior. So now what happened is that before I ran my update, nobody was making this much money. Afterwards, 49 people are now making a much bigger salary than they were before. But 58 people, and I can say this because I know the employees table has 107 rows, 58 people could not get that salary increase. But notice, no exception was raised. And I didn't check the contents of my Errorlog table, which is really bad. So let's go do that. I go back to my schema browser. Here's my table. Look at my data, and now notice I have 58 rows of errors. So in this case, every row is the same error because the same operation was attempted, but the application or row specific information is different. So there's my error number, error code. Here's my error message. There's the row ID, the type of operation. I didn't provide a tag, so there's nothing there. And then here are the values at the time that I tried to perform the update. And here's the number. That's too big. And as you can see, if I go through these different rows, the error is the same. The row ID will be different. And of course, the application-specific table column information is different. This is some very, very nice information. So one of the things we've been able to do is continue past the errors at the row level, and they are modified in the database table, even though we had these errors. And then afterwards, I can and really must check the contents of the DBMS error log table to see, well, what went wrong. And of course, the way I can do that is to run queries against the table. So I can say, well, how many errors occurred? What are the errors? And here are a couple of examples of that. So show me the total number of errors in my error log table. Whoops. And that's 58. And show me all the error messages and last names. And there's my data as well. So all that information is accessible to me, but I need to check right afterwards. So that's the core concept and example of the DBMS error log package and log errors. Now let's talk about gotchas, because this is one of those features in Oracle that is a fantastic idea, and it allows us to do something that you could not otherwise do. But they didn't quite finish up the implementation. They didn't think it through entirely. For example, the error logging table is missing some critical information. Let's go back over to Toad and take a look. So this is an audit table. It keeps track of errors that occurred in an error logging table. And it has a lot of information, but not everything I want. For example, it doesn't tell me when the error occurred. There's no timestamp. It doesn't tell me who was running this, which schema was connected when this code was run. And it doesn't tell me where in my application the update statement was issued. So this information is very useful, but it's sort of floating around in the ether. There's no context for it. In other words, if you run your DML statement and you do not immediately check after running your DML statement, and instead start running some other DML statements against the same table, you will not be able to tell the difference between an update that occurred now and an update that occurred 5 minutes later. That information is lacking from the table, rendering this technique, this feature, very uninteresting, very unlikely to be used in a production environment. In addition, error reporting is often quite obscure, and in other words, you get messages like table or view does not exist when the error log table is not present, instead of giving you a message like you're using log errors but there's no error logging table. Let's take a look at that. So if I now come back over to my schema browser and I drop this table, no more error log table, and I go back and try to run that same statement, here it is, log errors. I get table or view does not exist. Now, according to Oracle's security paradigm, it will not tell you the name of the table it was trying to reach, because that would be giving away too much information. But this is pretty hard to understand. You look at your code, update employees, well, the employees table is there, so why is it having trouble finding this? So be aware that you'll get these messages, and you really have to think through what you're trying to do in your application and what table it might be referencing. In addition, if your table is being accessed, you're executing DML statements from different schemas against a centralized data schema, and you have privileges granted to do those DML operations, you need to make sure that your error logging table has the same privileges as your DML table. In other words, it will not automatically do that for you. And again, you'll try to do an update of your employees table. That will work. But then it will try to do an insert into the error logging table, and you get an insufficient privilege error. So these are the kind of things you can run into when you try to put this to practical use in your production applications. Fortunately, you can get around most of these. And what I'm going to do is demonstrate that with my helper package. Now, the helper package doesn't address the issue of privileges. So if you're going to be putting log errors on a table that is being accessed from multiple schemas, you will have to directly grant or issue the grant statements for the error log table after it's created. But what I can do is help you with some of the key drawbacks in the error logging table structure itself, the lack of this critical information, and make it easier to maintain this code or the data. So the DBMS error log helper package will create the error log table for you, and then it will automatically add the 3 columns that you need: keeping track of the user, the timestamp, and the location in the code. Then it will also compile a trigger to populate those added columns. And finally, it creates a package that makes it easier to manage the contents of the error logging table. Remember, every error log table looks different. They have a different set of columns based on the columns in the original table. So the select statement you have to write against it will be varied. You'll have to write your DML operations against the logging table to empty it out and so on. So rather than have to do all of that yourself, I've provided a utility for you. So let's take a look at the DBMS Errorlog helper package. Now, I'm not going to go through all the details of the code. It's actually 350 lines of code. But the basic idea is that instead of calling DBMS Errorlog create error table, you call the create objects program. And you can pass all the same parameters that you pass to create Errorlog. And then you pass some other stuff as well. And I, again, won't go through all the details right now. But the basic idea is that it creates the Errorlog table for you, just like you would do yourself, and then it executes an alter table command to add the 3 columns: who created it, when was it created, and what's the call stack, where was it called inside my program. Then it creates a trigger that updates those values or sets the values on insert or update, though I think it'll just be an insert process. And then I create a package that's specific to this table that allows you to easily clear the error log, retrieve error log contents, and populate them or pass them back into a collection of records. So let's try it out. I'm going to drop the error table. I'm going to drop the supporting package, and then I'll create the objects. That's okay. And now, let's take a look at the error dollar table for employees. It's going to look different. Same 5 Oracle standard columns, the columns that it creates for us, and then created by, created on, and call stack. Excellent. And then if I look at triggers, there's now a trigger on the table, not very nicely formatted, but it's still there. And it calls the DBMS utility format call stack function to retrieve that answer, to answer the question, how did I get here in my execution call stack? If you're not familiar with this function, then watch the previous lesson in this series on handling exceptions. So there you go. All this stuff is done for you, and now when I run that same example, that same body of code that I ran before, and I get my errors. Again, no error was raised back to Plsql, but if I look in my table and check the data, here are all those 58 errors again. And if I bring up that one record, notice it was created by HR. It happened at 3 o'clock in the afternoon. And here's my call stack. Let's pull up the call stack in a format that we can appreciate. And there's the call stack. So all this information is now recorded for us automatically. Very nice. And then there's also a package created for us. So I can do things like this. Declare a collection that holds all the errors in my special error log package for employees. Retrieve the contents. And then I can iterate through the rows in my collection and view or log the information into a separate table, whatever I need to do. So I run this code. And now I see all the error information. And then I can easily remove the error log contents. So my suggestion is that you should definitely investigate using log errors. But if you're going to do that, take advantage of the error log helper. In fact, let's go through the conclusions. So first of all, whenever you're executing DML statements in your Plsql code, and you'll be affecting multiple rows. So for example, if I do an insert for a single row, that's not a good opportunity for log errors because you're just inserting one row at a time. But if I'm doing an update that might sweep across tens of thousands of rows, ask yourself, what's your policy? If an error occurs on any of the rows, do I stop or do I want to continue? If you want to continue, you'll have to use the log errors feature with DBMS Errorlog. And especially if you want to continue at the row level as opposed to the statement level. Statement level is basically something you can get with save exceptions. Row level only with the log errors feature. And then you need to make sure that you check and manage your error logs. If you don't, you'll have some very big problems in your application because errors will be occurring. There's no exception in Plsql, so you could just keep on going, but you're not going to get the behavior you want in your application. So check the error logs, create the error log table using the helper package, and then manage it with the error log package that's generated for you. All right, next steps. If you haven't already, download the demo zip from Plsql Obsession. Run the examples of code that I showed in this session. In this lesson, there are a number of very interesting aspects to DBMS error log and running DML and raising errors. Make sure you're thoroughly comfortable with what's going on and the added value and some of the gotchas of the log errors feature. And then you'll be ready to watch the next webinar in this series, which is Best Practices for Error Management. So I finish up my series on error management by giving you some guidelines about what to do and not to do in the way you work with error management in your Plsql applications. And I also offer you the Quest Error Manager, a free utility that will do a lot of generic error management for you. Hope you enjoyed this lesson, and happy Plsql coding.